Well, hi everyone. Okay, here's the practice test. The first part of the test will have a non-calculator part. You finish that, you'll turn it in, and then come get the part where you're allowed to use your calculator and get it out. Alright, so the first thing I have is we have this greatest integer function, and we're going to answer 1 and 2 with that, and then we'll give some equations here. So let's just get right to it here. Now, number 1 here, I got a negative 2.4 minus 2, and that is 2.4 minus 2 is 0.4. Okay, now the GIF of 0.4 is 0. Negative 0 is 0. Now, on this one, you get this negative. You got 1 and 7/8 minus 2. And we, that's negative 1/8. Okay, now, you round down to the nearest interval, so that is negative, that negative's here, this is negative 1, a double negative 1 is 1. Alright, and then I'm just going to do this. 0.75 minus 2 is negative 1.25. And if I round down, that is negative 2. Double negative 2 is 2. Okay, negative 2 minus 2 is negative 4. And that's just double negative 4, which is 4. And then 3 minus 2 is 1. GIF of 1, I'm just going to write this answer, negative 1. Okay, now we got to graph this function. Typically, the parent function, the first step would look like that. The second step would look like this. Alright, we are going to go 2 units to the right with that. So let's take this, put this endpoint here, here. So it's here. Alright. And it would be going up. I'm just doing it and just erasing rather than leaving it all on there. Okay, that is moving it 2 over, but this is reflected over the x-axis with that negative. So I'm going to take this one, this stays. I'm going to take this one and move it up here. Take this one, move it down here. Erase these two. And then just draw for the rest of the graph here. So just study the transformations. What difference is. The negative outside is over the x. If it was a negative inside, like a negative x inside, you remember we would be going over the y-axis. Okay, so let's try to remember some of those things. I'm looking at this one. This is a cubic function, but it is negative. Looks like we've gone 1 unit to the right, 1 unit to the right, and 2 units down. So I'm going to go 1 unit, and it does look as I go 1 unit from the middle. I don't think we have stretched it or anything like that. So I'm going to go x minus 1 cubed. Okay, and then minus 2. But it is negative because it's falling instead of going up. So we flipped it that way, and I'll just put an f of x in here. Okay. This one looks like a quadratic. So I'm going to go one right. So I'm going to go x plus 1 squared and 3 down. Go minus 3 there. And if I go 1 unit to the right, it looks like I'm going 2 up instead of 1 up. So it's being multiplied, stretched by 2. And this one. Okay, the typical square root function does this. This doesn't look like it's being stretched or anything because 1 unit and 1 unit, but it is looking like it's been flipped over the x-axis. So I'm going to put a negative square root of x plus 2 minus 1 out here on the outside. Oh dear. Oops. Okay. So reflected over, yeah, that's what it looks like to me. All right. Now, that would be where you would just turn in your that paper and then come and get this part, where you could use your calculator if you want. So f of x equals 4x plus 3, g of x equals x squared minus 25. We're going to find the following here. F plus g. F of x is 4x minus 3. G of x is x squared minus 25. Alright, just combine. And I'm seeing x squared plus 4x minus 3 minus 25, so minus 28. Let's subtract them. 4x minus 3 minus x squared minus 25. So 4x minus 3 minus x squared plus 25. So I'm going to write negative x squared first. Plus 4x minus 3 plus 25 plus 22. F times g of x, 4x minus 3 times x squared minus 25, and that's 4x cubed minus a 100x minus 3x squared plus 75. And I'm just going to put them in descending order of the exponent. 4x cubed minus 3x squared minus 100x plus 75. F over g of x, just simply write 4x plus minus 3 over x squared minus 25. I'm done with that. Now, but we want the domain of that, part E. And if you factor x squared minus 25, you'll get x plus 5 times x minus 5. And you'll see x equals negative 5 will make this 0, or 5. That makes it 0. So if I'm going to write the domain, you can't have negative 5 or 5. I'll go negative infinity to negative 5 to positive 5, and 5 to infinity. Alright, that's one way of expressing the domain there. Alright, given that f of x equals square root of 2x plus 5 and g of x equals x squared, find the following. F of g of x. So that is f of x squared, which is square root of 2 times x squared in place of the x plus 5. All right. G of f of x. That is g of the square root of 2x plus 5, which is, okay, so we take the input and we square it. We take the square root of 2x plus 5, we square that, and we get 2x plus 5. Domain of f. Okay. 2x plus 5. I'm going to do right here. 2x plus 5 is greater than or equal to 0. Means 2x is greater than or equal to negative 5. So we could say, I'm going to use just an inequality this time. F is greater than or equal to negative 5 halves. G, all real numbers. F, circle G. Okay, all real numbers. F circle G. Okay, so the G of x, all real numbers can be in it. But then we have restrictions from that because of this square root. Now this is a little trickier. 2x squared plus 5. That has got to be greater than or equal to 0. Which means 2x squared has got to be greater than or equal to negative 5 halves. X squared has to be greater than or equal to negative 5 halves. Wait. Okay. On second thought here, if I square something, multiply it by 2 and add 5, it is always going to be greater than or equal to 0, no matter what. So, F circle G is all real numbers. G circle F. Okay. Now, F has to be greater than or equal to negative 5 halves. Okay? So we have at least that much. We could have less. Or at most that much, I should say. Okay? If I go through, there's nothing that will make it smaller from x is greater than or equal to 5 halves. So that is, got to understand that the inner part, you got to honor its domain, and then you may have to make it smaller, but the square is not going to make it smaller. So make sure you start with the inner part and then see if it needs to be made smaller once the composition is made. Okay. Now, this one, show that 3 minus 4x and 3 minus x over 4, well, f of x equals 3 minus 4x and g of x equals 3 minus x over 4 are inverse functions, both algebraically and graphically. All right, so I'm going to just start algebraically. And remember, we want to show that f of g of x is equal to x. And we want to show that g of f of x is equal to x. So that's f of 3 minus x over 4. So we are putting in 3 minus x over 4 in place of the x. 3 minus 4 times 3 minus x over 4. All right. So I'm going to cancel out these 4s. I still have this negative here, though. So it's 3 minus 3 minus x, which is 3 minus 3 plus x. 3 minus 3 is 0, so that's x. G of f of x. That's g of 3 minus 4x. So 3 minus 3 minus 4x over 4. So that's 3 minus 3 plus 4x over 4. 3 minus 3 is 0. 4x over 4 is equal to x. Okay, so make some statement here. Since f circle g equals g circle f, which both equal x, then f and g are inverse functions. Okay, graphically, I'm going to graph y equals negative 4x plus 3, just thinking of it that way. Here's 3, negative 4, down 4 over 1. I'll make a decent graph here. Okay, so no, missed a little bit. All right, so there's that. And let's graph. I'm going to think of this as y equals negative x over 4 plus 3/4, or negative 1/4 x plus 3/4 in terms of y equals mx plus b. So 3/4 is right around there. If I go down 1, I'm down here, over 1, 2, 3, 4. 1, 1, 2, 3, 4. Let's go up 1, 1, 2, 3, 4. Okay. And hit that line. Okay. Now, I'm also going to draw y equals x. And I'm pretty close to hitting the point of intersection. Is pretty close to hitting that line. It should be exactly hitting that line. Just give myself a little bit of leeway. But I do feel like I'm seeing a reflection over the y equals x. All right. Okay, I'm going to write y equals f of x, which is this one. Y equals g of x, which is this one. Reflect with respect to y equals x, which concludes that f of x and g of x are inverse functions. Okay. Okay. Now 7 and 8, we're finding inverse functions. Find the inverse function of g of x equals square root of x minus 10, and give the following. So let's do this. Y equals square root of x minus 10. X equals the square root of y minus 10. I'm going to square and square. I got x squared equals y minus 10. Add 10 to both sides. I've got x squared plus 10 equals y. So I'm going to write g, the inverse of g of x is equal to x squared plus 10. Alright, domain of g of x. X is greater than or equal to 10. I'm going to write that as the range of the inverse. Domain of the inverse function here is all real numbers. Okay, I'm doubling back here a little bit, guys. This is 10 right here. Okay, if I'm going to get the true range here of g of x, I'm going to just use the function g of x, and x is greater than or equal to 0, which means okay. Now let's get proper. G of x is greater than or equal to 0. The inverse of g of x for range, we got to do that. Okay, number 8. Find the inverse function. So let's do this. Y equals 2x minus 1 over x plus 3. And multiply both sides by x plus 3. And I have xy plus 3y. And that cancels, equals 2x minus 1. Okay. Alright, back up. Okay, I didn't switch them around yet. Thought this was a little too easy. Alright. X equals 2y minus 1 over y plus 3. Okay, I'm going to multiply both sides by y plus 3. And I have xy plus 3x equals 2y minus 1. Alright, let's factor out an x there. So x times y plus 3. Okay, let's not do that. Let's, I apologize, guys. It's a little late for me to be doing this. But, okay, so what I need to do is get the y's on one side. So let's subtract 2y from both sides. Let's also subtract 3x from both sides. So get just the y terms on the left side here. So I have xy minus 2y equals negative 3x minus 1. Now, I'm going to factor the y out of these two, and I have y times x minus 2 equals negative 3x minus 1, and I'll divide by x minus 2, And I've got y equals negative 3x minus 1 over x minus 2. All right. And notation-wise, I do this. Inverse of f of x is negative 3x minus 1 over x minus 2. Domain of f of x. These are the x values. On f of x, I'm going to do this. I'm going to say negative infinity to negative 3. I'm looking up here. It can't be negative 3. Negative 3 to, whoops, comma, to infinity. And then this interval notation, okay, the domain matches the range. Now the range of f of x will match the domain of the inverse of f of x. Okay, that's all except 2. Alright, so I am going to negative infinity to 2 and 2 to infinity. Negative infinity to 2 and 2 to infinity. Alright, you guys take care, and really pulling for you to do well.